Hello, I'm standing here with Johannes Oswald. First of all, can you give us a short introduction of yourself and maybe what's your role in the project?
Yeah, sure. So I'm Johannes Oswald. I'm from the Institute of Space Systems of the University of Stuttgart, which is located in the southern of Germany. And my role is I'm doing a Ph.D. thesis on the topic of the MEESST project, which is related to the influence of the magnetic field on the high entropy plasma, meaning like we have a lot of electrons and a lot of ions, and we try to see what is the influence of a magnet and the magnetic field applied to the plasma column in the end. And we are hoping that we see some significant effects, for example, also on reducing especially the heat coming onto the probe itself. And this is then giving us the opportunity to transition our fundamental research from my PhD towards an application, for example, like a heat shield for a re-entry case.
Over the last 3 years that you've been working on the project, what would you say was the hardest challenge to overcome condition-wise?
So the hardest challenge for us, condition-wise, would be that during COVID and so on, we would have had a hard time to have the communication between each partners, which improved now a lot since COVID is over. And also the exchange between the partners was in the end challenging due to the situation. Aside from that, there are also problems with finding suppliers due to the situation with the Ukraine war. And this was some of the challenges we had, especially the communication between the partners, where you can't have like in-person meetings was one of the challenging parts for me to get to know in the start to the other members and etc. Yes.
Okay, and now from a technical point of view, what would you say was for you guys and your part of the project the most difficult technical problem that you guys had to overcome?
I think one of the most technical problems was for us in the end to one side, as we are doing both, we are doing simulations and also the experimental work. I'm more on the experimental work while my colleague is doing the simulations. One of the most challenging parts was to improve without having actually the probe already manufactured, and to improve our numerical codes and also to have already estimations of what we should expect from the probe itself to be operational, how it runs. And since on the technical side the system is very complex, it was hard to understand kind of how should the system behave in the end, how can we implement it in our plasma chamber. This was very complex to find the solution, the safety, and how to handle this new system, which was also new to us, cryogenics, how to implement this in our facility. This is one of the challenging parts, technical side.
Would you also say that this was the greatest achievement in your work?
Yes, so one of the greatest achievements is and will be that the probe itself is functioning and operational within our plasma conditions. You have to imagine you have on the one side you have a gas flow which is at around 10,000 Kelvin, which is twice as hot as the sun's surface, and on the other side you have a magnet which needs to be an operational temperature of around 30 Kelvin, which is the orders of magnitude are between those two sides, and there's only about this much space between both surface areas. So
it's like minus 240 degrees
yeah, it's
Celsius.
minus 250 to 260 degrees Celsius, so very cold. And yeah, this is one of the greatest achievements, I say, is to be able to have this implemented and also having a lot of gaining data on the understanding of the magnetohydrodynamics effect correlating with the magnetic field and the influence on the inflow particles. Yes.
Perfect. Thank you for your time and thank you for the interview.
Thank you very much.